Hey everyone, got a weird thought pondering in my head. It's funny, I've been thinking, you know, some people are like, this guy's thinking? Whatever. Anyhow, most people might know about the Einstein thing, right? E equals c squared, right? So it's the mass energy equivalency principle, right? Energy is equal to mass, and you got c squared here. C squared is a little weird here because it's a result of things that happened and canceled out, and I'm sure there are other videos that could explain it better than I can. But I found something that's still interesting or odd about it, and I think it's like an oversight, and I don't know why. But I feel like it can go into something else because it turns out there's this other thing in physics, right? Um, and it's funny because it has to do with areas where there is practically nil or zero mass. Like the mass isn't there, and that would be vacuum. And more specifically, a true or absolute vacuum. And there are two values associated with it. With so the true vacuum is associated with these two values, and these things are phenomena that have been measured in physics, and they are, what is it? I'm trying to remember which is which, but they are, I want to say, one is, this is permeability or permittivity. Well, there are two different things, but they have similar sounding names. But hold on, do I have a reference? But these things are have to do with charges and fields, like electromagnetism. So permeability. Permittivity. And what they do is, if there's like a charge, like a little charge, and it happens to be moving wee, through space, there is actually something that is pushing back against that charge moving through space. It's like a resistance. But this value is very small. I don't remember the numbers offhand, but it's a very tiny value, and this pushback against a charge moving through a vacuum is this very small value. So, like, what's pushing back against it? Good question. Like, why is this charge seeing resistance when there's a supposedly an absolute vacuum, nothing there? And permeability is like the same thing, but like if you had a magnet doing this thing, and you try to move the magnet, let's see, like you were spinning it or something, and the magnetic fields, if they are moving, the fields themselves also get a resistance to movement. Something is pushing back against the moving in a vacuum. So, like, what's going on with the vacuum? And I think this has something to do with what's that experiment? The Casimir effect experiment. Like you get these two big plates of lead or whatever, and you put this really tiny gap. And these plates, they want to push themselves together. guess. There's something strange going on there. But, like, a similar thing, there's, like, if you have them in a vacuum, there's nothing there going on, but they still want to go together, and it's not gravity, so. But this ties back into gravity, because what I'm thinking is, it also happens to turn out, if you take the product of the permeability, or I don't have it on hand. I've been reading these things, but for some reason I don't have it memorized that well. But if you multiply these two things together, like this, multiplication, like in algebra, you just slap them together. I don't even need the brackets, but just to show these two things together. And it happens to be the same. It all cancels out. There are other attributes, they cancel out. And they are c squared. So this is a property of the vacuum state, and it's c squared. And it happens to be equivalency, right? E equals c squared. This is this. It's the same thing, so that means this would also be this if you consider that they are equivalent. So what that would also imply is if E equals mc squared, and therefore if you wanted to figure out what mass is, why does mass have gravity? So mass, what you do is move to c squared, you divide both sides by c squared. That. So these would cancel out, and mass therefore is mass equals energy over c squared. So therefore mass would also equal to energy over the properties of the vacuum. So if you want to do it, I don't know if the order matters, but the permeability and permittivity of a vacuum, the resistance of things moving through a vacuum. And I may not be a much of a physics guy. I'm kind of a lay person, and a bit lazy on the math, unfortunately. But nonetheless, these are substitutions, and I'm just like seeing this here, and I'm like, what is going on here? And basically, mass is a ratio, because like energy, if you think about it, it's a potential energy, kind of like how voltage works with electricity. It's a similar thing. It's a potential. Because this represents the mass. It's the energy that the mass is stored within the mass. So this is a potential, and this is the background. So if you think about it, it's how much energy there is versus the vacuum background, the background of the energy, and you get mass out of it. So there's this thing like a gradient. Hold on, I'm going to have to go break your immersion of the whiteboard into my graphics software here, but do I have an airbrush? And well, let's do this first. I'm going to, and I'm just going to say this is the background, right? This black area is the vacuum. And then you want something soft gradient, and so I have this, right? This is like energy, and it's a gradient. See how it's going from light to dark. So this is an area of energy, and we have a gradient here. So notice that you have light area of energy and the dark area of vacuum, right? So like say this little ball here is energy, and this little area is a vacuum, and there's this gradient. And it goes all the way around here. Gradient, right? Well, there's this thing. Notice that you have rise over run. It's a slope. So you can take the derivative of a slope, and what that would be called is, there's the thing to do with gradients like that, and you do your slope, and you get this stuff called tensors. It's still a little bit beyond me, I think, but nonetheless, you have rise over run. So if you were to take the tensor of that, you would get something to do with gravity. And I think what it is this is the phenomena that creates the acceleration. But the interesting thing is, this tensor math stuff is used with electric motors. Maxwell and all that, it's been proven, is how your like electric cars or electric motors. So I am thinking the motive force of gravity is a tensor effect or something like that, right? So, and this is the property of the vacuum, and I'm going to go with another analogy. Oops, why did I do that? For whatever reason, you decided to use the background color. Like that. Yeah, that's what I want. Drawing again, pardon me. So, you know how you have the rubber sheet analogy? Like where it goes in, and then there's like the ball on the rubber sheet. Sure, you've heard of it, you've seen it in explanations all the time. Well, it turns out that the ball isn't mass, but it's energy. It's the energy equivalent principle. So this ball is energy, and this rubber sheet is the background vacuum. So basically what you are having is the ratio of energy versus, I don't know if it matters what order they're in. It could be the other way around. They swap back and forth, but you know, I tend to like writing it this way though. It's the same thing as this. And if you look at this ratio here, this is the interface or interaction, and this slope is the tensor. I'm it's a derivative property. It's a delta, but for whatever reason, it's tensors. You go upside down, but you know, dy over dx kind of thing. You know, deltas, that kind of shit. This is a ratio, so you have that, and if you're seeing the slope describes this acceleration field in this curve, or the slope of the slope even. I think that's what it might be. You know, that would make it a tensor curl. I don't remember if I think it's like that. Is that it? Well, I'm kind of rough on reading it, but there's this effect, and I think that's what gravity is. It has something to do with this relationship, energy versus the background properties of the vacuum. And the vacuum is this tension. Because most explanations tell you, oh, this is the mass and this is space-time, but they don't tell you like what is going on with space-time. But this is the vacuum, the properties of the vacuum. Describe tension or elasticity not over, but oops, that's a L, not a V. Why? My handwriting is just off because I got my elbow on something. I'm using my tablet. ELAS. Why am I? tension or elasticity, vacuum properties. My writing is bad today. It's just my brain's a little scattered. I got so many distractions in life. It's stressing me to freak out, but I'm still trying to explain this because I can't drop it on my mind. It feels like an oversight, like a big one. Describe tension or elasticity of space-time. So, energy is what is going on here. This is a factor of energy density, energy per unit volume. So, where you have more energy density, this is what's going on relative to a volume of space. So, you have more energy per unit of volume, and it is pulling against this aspect that resists the movement of energy in the form of electromagnetic properties. So I'm also thinking there will be electrogravitic effects, but most people dismiss them as being a thing, right? So electrogravitism requires you have a charge. That's why it's dismissed. So electrogravitism requires a charge. Charge or a field, just like magnets, you know? If those things are there and they're canceled out in neutral, you just have plain gravity. And that's why astronomers, they don't want to deal with all the magnetic fields and the chaos and all that shit, so they just dismiss it. And there's this thing, a charge, a moving field, electromagnetic field, associated with the mass, which is an energy potential. Otherwise, it cancels out. So, this is the thing that I think should be looked into. Because most people describe it and they don't go into the specific caveat. And I think this will be an exploit if you want unusual propulsion technology. Because someone will do like lifters and all that stuff, and here you have a charge, and you have the mass of your plates or something here charged. But notice that it does take a crap load of energy to produce that charge. So this is not like something cheap. It's not like a free ride. At least unless you can do something about the aspects of the vacuum itself. And I think there might be a loophole there. Honestly, I want to see people get off this rocket. Rockets are neat. And I know Elon's doing his thing with SpaceX, but I think there's another trick or two, and we're just stupid monkeys overlooking this stuff. Our primate humanoid species is kind of stuck on something, and I think it is not that complicated, and we already have the things to describe it, but for whatever reason, it's just not been looked at. So I'm just another idiot monkey trying to contemplate that. So if electrogravitism is a thing, how do we prove it? And I am thinking that it has to do with like planets and stuff, orbital bodies going leap around. And if one thing has more of a charge, it's not like an atom. These are like, this is a star, right? This is a star. Let's say the star is pushing out solar wind, and the solar wind is carrying charges. Well, the star is going to be more charged. Maybe it's positive or negative, but regardless, there is a difference here. there is a delta, right? There's a difference in charge between two gravitational bodies in relation to each other. So this is going around in orbit, and this is a star, but they happen to have differences in charge. They are not the same. Maybe, and when you have differences in charges and there's a movement, there is electromotive force, and that movement will act like a motor, and because this is moving through the magnetic fields associated with the star, and of course it has its own magnetic fields, but because this is moving in orbit around the star, and there's differences in charge here, this thing that is a planet is going to want to turn like an electric motor. Same kind of reasons too. So, some will say, "Oh, it's the inertia when the planets formed." But when the planets were forming from their little chunks of matter going in and whatever, what was put in that force that caused this vorticity in the first place? The same thing. So, the reason planets spin has to do with electrogravitism. Some aspect of that. Can't say it's entirely the case because, of course, you have inertia and things bump around. You have stuff like rogue planets in space, but I would think that if you do a free fall test, if you drop something and it's going wee, free fall, and if this thing has a significant electric charge, positive or negative, but if you were to put a big enough charge on it, this thing in free fall will want to rotate. It will see a torsion. And I think that will be a test for electrogravitism. My suspicion or hypothesis is that this will be in effect. If it is not carrying a charge, if there is no charge, then there will be no spin. It will just be, like as you usually know it. So these things are related, I suspect, and I think that is something to do and look into. And even if it seems crazy, because I can't claim to be as good as Einstein, but it's just like crazy. But test these out. So mass you can write it this way too. And that will explain gravity to some extent. Is that the big little g or is this the big T? One of these two. Something like that. But anyhow, there's something going on in there that's overlooked, and I think if there's some digging into it, you'll find some interesting stuff. And this will, it's basically taking your Einstein stuff and you're feeding it back into things that Maxwell and likes of him messed with. And you can probably tie them to Newtonian stuff. And with Casimir plates, you also have your quantum effects, your virtual particle pair cancellations and stuff. So these things kind of tie together in ways, but still not sure how to describe. And somebody smarter than me with the math part of it will have to do that. But I'm just looking at like rough equivalence type stuff or things I found and digging around poking just because it seemed weird. And yeah, I think there's an oversight here, and digging it, and I know there's stuff I googled looking into it and talking about the elasticity or space-time and finding the Young's modulus of space-time, and it's kind of weird, but it's neat. But I'm kind of just trying to poke if there's like some trick, because if mass is energy over the vacuum background like this, there's some trick. Can this be altered? Can we alter this? Energy, it takes a shitload of energy, huge, to get an effect. We're talking like planetary bodies like Jupiter being converted into energy. this is on a denominator. Can we affect this? Because if we can figure out a trick to mess with those properties, we got a loophole to get off this little rock in space. I think that would be kind of neat. And their UFO, UAP stuff and all that, maybe there is one, but it's just not in the public domain, but can we make it that way? And, yeah, it's goofy, but I'll leave that for you to make out, decide, talk about, and I guess that will be it. So, that's it for now. And there you have a weird idea to think about. It usually has nothing to do with what I normally do on my YouTube channel, so there you go.